But now let's formally define dependence and independence. Well, I guess we're formally defining independence. So again, if one does affect the other, dependence. If one does not affect the other, independence. Mathematically, the probability of E given F is just the probability of E. So for instance, probability that you passed a math test given that you brushed your teeth is just the probability that you passed your math test. Because brushing your teeth does not affect whether or not you pass the math test. At least not today. So those two events would be independent of each other, and that's what that means in symbols there. Because of that, we have the product rule for independence. The probability of E and F is the probability of E times the probability of F. So if your events are independent, then you just multiply their corresponding probabilities. Once again, well, actually, this is the only time where I give you the formula before we're doing an example. So we're going to do an example called product rule of independent events. Let me make sure. Scroll in my notes. Yep, you're going to do it. And it's not going to be much different than what you've had before. Just again, and if you're doing more than one thing, means to multiply. That's all you're using here. Good luck.